I'm Eric Cheddar. I'm here to talk about event-driven data with Apache Druid. What does that mean, really? Well, fundamentally, it's a discussion of kind of a pattern that I'm seeing unfold working with Druid, working with customers, working with people in the community, and what they're actually trying to achieve in using data. And now there's that big title with a bunch of words on it, but the way I like to introduce myself is that I wrote the first lines of code on the Apache Druid project many, many years ago. I talk about it that way because the first lines of code and where the project is now are a very different thing. And so I'd like to start by actually talking about where the community has gotten to. We've had over 22,000 community members, over 550 contributors, 2,000 plus companies using Druid. And in this last year alone, there was a 150% increase year over year in community activity and engagement. And now this is a testament, not to me, not to the people at Imply, even though we do a bunch of stuff in the project, but this is a testament to everybody in the room. And so I'm going to do the trite thing, and we're going to take a moment for everyone to applaud ourselves on what we've done in the community and pull it all together. But like I said, I'm going to talk about a pattern that I'm seeing, what I believe is emerging in the data world. And I'm going to use this with a backdrop of a couple of companies that are kind of known at using Druid. And so we're going to start with Netflix. I assume everybody in the room here knows about Netflix. It's pretty much a ubiquitous company now. It introduced the idea of streaming content to the world. 270 million paid memberships, 190 countries, global phenomenon. Netflix uses Druid for an observability use case. They take the playback devices, they generate some logs, throw those in, they process the logs, generate telemetry events, funnel that into Druid, use it to understand which videos are most popular, what people are viewing things, the playback rates, things like that. And Netflix is a famously data-oriented company. They use this data to make business decisions on a daily basis, understand what type of programming to invest more in and drive after things. And that's just one of the companies I'm going to use as a backdrop for this. Another one called Ibotta. Ibotta is a cashback, it's a cashback deal platform. What can happen is a maker of a product can go on, they can put in information and say, you know what, if someone buys my product, I want to offer them a cashback thing. Kind of, you can think of it as a coupon a little bit. And then consumers can go buy products, register that they bought the product, and get cash back from Ibotta. Over 200 million consumers, $74 million in cash delivered back to consumers. But if you imagine a company that's built around giving money back to people, there's going to be some people out there in the world who are like, you know what? I want you to give me money, and I don't want to buy anything. And so you can imagine Ibotta has this issue with fraud and security, and they need to understand how are the cashback deals being redeemed, who's redeeming them, and what's going on. They have to understand all of those activities in order to dig in and protect themselves from fraud. And now, if you think about this a little bit deeper, it's not just one user. Because at one user doing fraud, you can kind of track that relatively easily. But like crime syndicates can get pretty sophisticated. They can be groups of users. You can leverage a bot farm. You can do all sorts of things to try and trick the system into giving you money back. And so their needs aren't just following one user, following what's going on, but understanding holistically what's going on in the system, being able to look historically, being able to group arbitrary sets of users to really understand and do the forensics to figure out what happened. And so this is a fundamental thing that they use Druid to help them resolve. Now, another company I'm going to talk about a little bit is Reddit. Most people in the room have probably also heard of Reddit. It's a primary source of information. Over 100,000 communities, 82 million daily active users. I know when I Google questions and stuff, Oftentimes a Reddit link comes up. I click on that as one of my preferred sources of information because it's local, it's people, it's real information. You get stuff from there. Now when I click on that, that page shows me an ad. It's usually relevant. But for their digital advertising, they pump all of those ad impressions into Druid. They push that data in, use it to understand what are the demographic breakdowns of the different subreddits. What are, if I'm an advertiser and I put an ad on, what kind of user, what kind of reach am I going to get? What bid price should I be putting down? And understanding all of that information to kind of know what's going on. Now, I said I'm introducing these companies as a backdrop to kind of a pattern or an evolution that I'm seeing in the data world. And that is fundamentally that I think the distinction between OLTP and OLAP has kind of run its course. It's not that it's bad, it's not that it's wrong. It's just run its course. And why I say that is that it's fundamentally very infrastructure-centric. We've all learned in Database 101 that OLTP systems, online transactional processing, you use that when you want to create an application. And because you need the transactions, you need to update things, you need ACID compliance and all of that stuff. And then OLAP, online analytical processing, you use that because when you're running across all of those rows of data, you're going to ruin your page cache in the OLTP system. And you don't want to fight with the page cache for your analytical queries and your OLTP queries. And so you put that in another system. And by the way, while you're putting in another system, you might as well optimize the storage. You might as well optimize the indexing and processing in order to be able to deal with the queries that you're handling. And there came OLAP. Now that whole explanation that I just gave, it's all infrastructure, it's all technology. None of it is focused really on what people are trying to do, what people want to use that data to accomplish. And that's fundamentally where I say that the distinction between OLTP and OLAP, I think, has run its course. And now to talk a little bit more about this, let's think about the types of data that you put in each of these systems. In the OLTP system, taking Netflix as the example, the OLTP system has the video. When someone comes to upload the video, they'll put the title in, they'll put the regions it can be viewed at, they'll put the time range it's okay to view that at, and all of the metadata about the video itself. In the OLAP system, it's the playback information. It's what interactions happened on the device, on the playback view, when was play hit, when was stop hit, what was the overall view duration, all of the playback information, what happened when someone was viewing the thing. Going to Ibotta, it's the cashback deal is what you would put in the OLTP system, that the manufacturer, the maker, the seller would put in stuff, I have this product, I want to offer this % cash back to anyone who buys it, run it between this time range. But what goes in the OLAP system is the redemption of all of those cashback deals. It's this person went to this store, they bought this product, and now they want money back. You go to Reddit, it's fundamentally a similar pattern here. What's in the OLTP system? It's the community data. Who are the moderators? What are the actual posts? What are people typing, writing? Which people are following which community? Then in the OLAP system, it's those interactions. Who viewed it? What did they see? How long did they stay? What ad was seen? What impression happened? How much money came from that? And we have this separation. I'm not sure if you're noticing, but there's a separation actually that can go back to English grammar between these two. And fundamentally, the things in the OLTP system, they're all nouns. It's the video, it's the cashback deal, it's the community. The things in the OLAP system are all verbs. It's the redemption, it's the view of the video, it's the interaction. They're all actions and activities that are happening in the real world. And this fundamentally amounts to where the separation that OLTP and OLAP has pointed to still exists, it's still there. I think it's much more interesting to think of it in terms of the data rather than the infrastructure. And so thinking of it as the data, you think of it as entities versus events. Entities are the nouns. They're things in the world. They're actual physical objects that we interact with. Events are the actions. They're the verbs. They're the things that you do with that interaction. So going into a little bit of an example, let's take this conference room, and we'll talk through this. But take this conference room. This conference room is an entity. We have quite a number of people in here. Let's call it 150. When that conference room door opens and someone else comes in, it goes up to 151. That one, there was an event. Someone entering the room is an event. It happened at a point in time. It made the conference room have 151 people. If someone gets up and leaves, we go down from 151 to 150. That, again, is an event. It happens at a point in time and changes the state of our conference room. Following the example on the slide, you can have a similar thing. You can have a room of 3 people. One person enters. Great, we have 4 people now. 3 people leave. Okay, we have 1 person. The lights turn off. How many people? I don't know, we can't see. 5 people enter. Did they really enter? I don't know, the lights are off. We still can't see. Lights turn on. Yay, 6 people. We have them all. You can see that as each event happens, the state of this entity is changing. And so there's an intimate relationship between events and entities, where events are always verbs on entities. They're always representing state changes on an entity as it happens. And the other thing with events is that events represent state changes on multiple entities at the same time. It's not just the conference room that changed. When a person entered the room, that person is another entity in the grand scheme of things where their state changed. When they sit in the chair, the state of the chair changed as well as that user. You go back to the Netflix example. With the video view, there's the video that was viewed, there's the device it was viewed on, there's the network provider that provided the internet for it, there's the end user who actually viewed it. You go to Ibotta, you got the cashback deal, you've got the store they purchased it from, you've got the item that was actually purchased, various entities there. Reddit, you've got the ad campaign, you have the community, the subreddit that it was actually on, you have the posts that people viewed. All of these are different entities. And this is important because as people working with data, as people working on these systems, this distinction, I believe, is fundamentally the central theme that you have to figure out and think about when you're architecting and designing what it is you're trying to do. Are you modeling an entity? Are you modeling events? Or is it a mix of both? And it turns out that this often ends up as a mix of both. Now, as a backdrop to this, there's another thing that's been going on in the industry. For the past 10, 15 years, the database, the traditional database that you learned about in Databases 101, has been undergoing a decomposition, a service decomposition, a microservice decomposition, where the different parts of that traditional database have been extracted into independent different services. So think about the database that you learn about in DB 101. You've got the write-ahead log, you then have some storage medium, and then you have some query processing that runs against that storage. 10, 50, I don't know how many years ago, Kafka came along, introduced pub sub. People are like, you know what, let's pull that out, let's make that its own thing. That's fundamentally a write-ahead log. It's fundamentally the service decomposition, pulling the write-ahead log out of the traditional database and making it its own independent piece of infrastructure. You have all the object stores. You have S3, Google Cloud Storage, Azure Object Store. All of those are fundamentally that storage layer. They're an infinitely scalable storage layer of the traditional database, where they're just providing the storage and everything that's going in there. And then you've got the query engine, where there's a lot of work going for how to query these things. And I think, I might be biased, but I think the stream, we've more or less kind of figured out the stream. It's well understood. There's a lot of work going on with Flink and other things to expand what can be done with it, do things, but like the stream, it's gotten its place in infrastructure and architecture. Object storage, S3 powers the internet. S3 goes down, the internet's probably down. Maybe GCS and Azure Object Store will cover for it for a while, but like object stores are everywhere. And they're a ubiquitous part of our infrastructure fabric as well. And so they've gotten their place. And with the advent of Iceberg and other storage formats coming in, there's a lot more iteration happening in the storage side. But this query engine side, this is the part of the world that I think is under the most rapid evolution right now. Because people are trying to figure out, okay, we know how to do the write-ahead log. It's the stream processing infrastructure. We know where to put storage, that's lake storage. What is the right query engine for this world? And this takes us to another realization. It's that events are actually the lingua franca of this decomposed database. And this isn't actually a new thing. If you go back to the traditional database, the traditional thing that you would have learned in Database 101, and think about what gets written into the write-ahead log, the write-ahead log. The wall has an event written to it. It's a verb. That insert statement, that change, that delete, whatever, it takes the command and converts it into a verb to write into the write-ahead log. It then executes that log against storage in order to provide for transactional consistency. You either see the data before the verb or after the verb, but you don't see it in between. And that's fundamentally the definition of transactional consistency. And so this idea of the event actually being the thing that goes between these different systems is actually fundamentally, it used to be an implementation detail of the traditional database, but when that got decomposed, it became a first-class entity in the overall architecture that has to be dealt with as it goes from system to system. But now we have this decomposition where you have the event coming into the stream, going to storage, and then querying. But with this setup, you have a little bit of latency added. You have some issues where data has to hit storage before it can be queried. That can take whatever amount of time that it takes. So as we evolve what the query engine has to be in this world, we realize that the query engine probably also needs to be able to consume from the stream. If we want to reduce latency. If you don't care about reducing latency, then maybe you don't care. But if you want to reduce latency and have the most rapid update, you need the query engine to be able to also see the events coming in from the stream as well as process the stuff from the storage engine. But then this marries together with the idea of entities and events, because when we get back to modeling our problems, when we get back to modeling what we're doing with data, you need this query engine to be able to reconstitute entities just as much as you need it to be able to aggregate events. And you need to be able to use that engine for doing both, because both things are fundamentally useful, and different problems require different things. And so fundamentally, as we get into what the data architecture of the future is, it's fundamentally, I believe, going to be this, where the query engine and all of the evolution of the query engines is basically going to be driving towards what it means to convert events into either entities or events, or aggregations of events, based on what it is that the product actually needs. So Druid, from the beginning, has started with an event-first mindset. The starting assumption where we started was events. It was digital advertising events in the very beginning, all about impressions and everything like that. But we came from this event world, and so we've been built with this assumption of events in place. If you look at some of the places where we're not that strong, we could be stronger, it all comes back to the question of, when you take those events, how do you model the entities? How do you work on them? How do you pull them together? And that, I think, is the future of where we're going in terms of things that we need to be working on, things that we need to be improving, and things that we need to be adopting. But in the meantime, this pattern, this decomposed database pattern, anybody who's using Druid, and all of the examples that I've provided, they're pretty much already using this pattern. Netflix has data flowing into a stream. From there, flows into storage, flows into Druid, exposed to the end world. They have that three-pillar pattern of the decomposed database. Ibotta, basically the same thing. Reddit, basically the same thing. And so this overall architecture of the decomposed database, of having your data streaming into a streaming system, funneling, and then dealing with the lake storage and the query engine, it's going to stay the same. The question is just, how are you going to plug in those dots? And for all the companies who are adopting Druid, you've got the architecture there. The question is just, how do we evolve it going forward? And that's kind of my message back to everybody, the thought I want to plant for everyone, which is, I'm going to put it on the thank you slide, but the thought is basically, as you're approaching your data problems, think first in terms of what entities are you dealing with, what events are happening around those, and what does your product actually need to expose? Are you exposing events? Are you exposing entities? What is it that you're dealing with? If you start from that, it makes it much easier to step back into the choice of infrastructure, the choice of how to set things up, what queries to do. And as we move forward in Druid, as we move forward working together and building stuff, there's an open set of work to do around what it means to come together and reconstitute those entities from events. And that's something that I'm hoping we can all work on together. With that, thank you.